Hey pre-calc students, we are wrapping up chapter 2 here with one last lesson that's really a kind of a throwback lesson to your geometry class. We've been working on expanding our knowledge of trigonometry to angles of rotation and defining every angle as a rotation of some ray around the origin, starting at the positive horizontal axis. But this lesson is just kind of a reminder that that's not how every angle exists, right? Like when we're doing things, right triangle trig that you learned in geometry is still a thing. So hopefully this is kind of a nice, easy throwback lesson for you, just to remind yourself, like, oh yeah, I have used this before to solve things and just missing, like, in right triangles. So we'll do 2 quick examples of this. We'll get some practice, and then, yeah. So first example here, you got a triangle, your angle down here, and we're trying to solve for x. So questions you want to ask yourself is, what are the side lengths in here? So really, when we're dealing with right triangle trig, u, v, and r are pushed to the side again, right? I've been harping on those hard, like we want to redefine our sine as v over r, cosine as u over r, tangent as v over u. There's not always a vertical and a horizontal and a radius. Sometimes we just have to go back to our right triangle trig. So looking at this question, right, I know my angle there is 37. I've got 2 other side lengths that I care about, right? So if I want to identify the side lengths I care about using that adjacent, hypotenuse, and opposite language, I know the adjacent side. I'm looking for the hypotenuse. I don't care about the opposite side at this point. So the trig functions involving the opposite side, I don't really want to work with. I want to deal with the adjacent and the hypotenuse. So for that, I'm going to be using my cosine function, right? Because cosine is adjacent over hypotenuse. And so every time, like if you have a question like this, don't do it in your head. I want to see the work. I want to see you set this up. And that's a big part of this, is what is the setup for this. So every time you have, it's the cosine of your angle, in this case 37 degrees, is equal to adjacent over hypotenuse. So that's going to be 19 over x in this case. Okay. And so to get x by itself, right, back to just algebra skills now, right, this is a little bit more complicated than if I was trying to find the adjacent when I knew the hypotenuse. In that case, right, if this was x over 19, I could just multiply both sides by 19. But since I have this x in the denominator, like I can't just divide by 19 and get x by itself, because x would be in this denominator. If I divided both sides by 19, what I would be left with on the right side of this equation is 1 over x, which is not what I'm trying to find, right? Like I can't get rid of that 1 in the top. So what I recommend doing is multiplying both sides by x. So we'll rewrite it again here to kind of just show fully what I'm doing. I'm going to multiply x on both sides so that it cancels there, and I'm left with x times the cosine of 37 equals 19, right? Like these have gone away now. Okay? And so now, to get x by itself, I would divide both sides by the cosine of 37. So I get x equals 19 over the cosine of 37. Plug that into your calculator. You'll get it's about 23.79. If I want to be thorough, right, put units on it. This thing was in miles, right? And then go back and check that it makes sense, right? If this was 37 and this is 19, does it make sense that this hypotenuse would be a little bit longer than this adjacent side if I kind of drew this well? Yeah, right. It looks like it's definitely longer. It's the hypotenuse. It has to be longer. And it looks like it's quite a like it's pretty close. It's a lot longer than this opposite side, but it's pretty close to that adjacent side. I can be pretty confident that, yeah, that is an answer that makes sense. So we're good. All right, next example, trying to solve for a missing angle, right? So above we were looking for a missing side length. What if I wanted to find a missing angle, right? It's the same thing. I'd want to see the setup, right? So I'm looking to solve for angle A here, right? Should have that specified. I'm looking for this angle, not this one. So again, I want to kind of forget the U, V, and R, even though this looks like it could maybe be in a coordinate system where the 27 is the U coordinate and the 16 is the V, right? Maybe it would be negative 16. I'm caring about this angle down here, not this one up there. So I want to be looking at, right, what are the adjacent, opposite, and hypotenuse sides for this? So if this is angle A, that 27 is opposite to angle A. Right, and the 16 here, this is right next to angle A. It's my adjacent side to angle A. So to set this up, I'm going to be using the tangent ratio. Right. So my setup, it's going to be the tangent of A is equal to opposite over adjacent, so that would be 27 over 16. So to get this by itself now, right, I want to get A. I can't like divide by tangent. That's not a thing, right? This is one of those pieces where I want to look at the inverse, right? The inverse function, the thing that flips the inputs and outputs. For a normal trig function, right, we put in an angle and it spits out a ratio, right? I know the angle, like cosine of 37 degrees. I could put this into my calculator and it would give me, right, some decimal answer. I didn't care about it right now. I just did it exactly here. Right, but I would put in 37 and it would give me a ratio out. For this, I don't know what I'm putting in, so what we want to do is take the inverse of both sides and say if the tangent of A is 27 over 16, then A is the inverse tangent of 27 over 16. Okay, flips the inputs and outputs. What was normally my output, this ratio here, goes into this inverse function and will spit out my angle. So if I plug that into my calculator, I get my angle is 59.35 degrees. Okay. Again, check and make sure that your answers make sense, right? If you're in the wrong mode here, if you're in a different mode and you plug this into your calculator, 27 over 16, I would get like 1.03, right? I don't want to do anything to that, right? I don't, like, some people like get an answer, like maybe you plug this into your calculator and you got like 0.59 or something. You're like, oh, that doesn't make sense. Let's just like shift the decimal spot a couple of spaces. I see that a lot. That's not how math works. I can't just decide like, oh, this is an inconvenient answer in my calculator. Let's just move a decimal spot a couple of times. There's probably something bigger going on there. Right? If you are in radian mode, if you're using Desmos, again, that's what it defaults to. So you could use Desmos for this, right? But it will give you the wrong answer unless you go in and change it, right? So I can kind of show you how to change that, right? If I wanted to do the inverse tangent, right, one thing you can do is, right, go to the functions here, and it has all of these different, right? I can do inverse tangent that way. And if I plugged in 27 over 16, again, this is not the right kind of number. So it Desmos defaults to, but it's wrong for if I want a degree to come out. So go in here and change this to degrees to get your right answers, right? One way that you can always check, like, what mode are you in, is do like sine of 30. That should be half every time, right? That half right triangle thing. So get out your calculator, plug that in, and if you're getting something different than 1/2, check your mode, right? And let me know if you have any questions on any of this. But that's it.